All right, let's look at the problem for the night. Compute the following matrix products if possible. And we've been given 5 parts A, B, C, D, E. So let's just talk for a minute about why we define matrix products the way we do. And then the next minute we talk about how is a matrix product defined. So if I had a matrix like this, 1, 2, 3, 4, and a matrix like this 3, 6, 7, 9, it's most intuitive for most people to do something like this. That is, multiply the corresponding places. This is something you can do. This is not defined as one of the common operations. I think there is a special symbol for this, but this is not what people usually mean when they say multiply two matrices. The reason for that is this, even though it is a valid operation and you can do this, it's just not very useful. And matrices were, linear algebra was really developed very thoroughly for computing and a lot of its applications. So when it wasn't very useful, we didn't do this. There's another thing that you might have noticed studying linear algebra is that you can also multiply a scalar with a matrix. So something like this. Again, of course, this is not something we generally mean when we say multiply two matrices. This is a scalar multiplied by a matrix. Now, the matrix multiplication that we are interested in is something like this. 1, 2, 3, 4, 2, 1, 3, 4. So you multiply the first row and the first column, and that gives you this element. First row, first column, so that is 1 times 2 plus 2 times 3, that is 2, plus 6, that is 8. So this is 8. This and this will give you this element. 3 times 2, 6, plus 4 times 3, 12. Correspondingly, you can find 1 plus 8, 3 plus 16. This is a fairly weird way to do it, but this is useful to us. As you'll notice, we establish lots of systems of equations which have already been discussed in the chapter of mathematics for machine learning, linear algebra. And so multiplying vectors like this really helps us reestablish systems. And that's why it's one of the main reasons why we want something like this, a multiplication that's defined like this. Righto. So since we have now talked how it's defined, we haven't exactly completely defined it. Remember, this is a 2 by 2 matrix, 2 by 2 matrix, and this gives a 2 by 2 matrix. An interesting question here, does this work if these dimensions change? Well, if the dimensions are mn and the dimension is pq, this can only be performed. Remember, this could only be performed if m were equal to p, that is 2 by 2, 2 by 2, as these would have to be of the same dimension, and then a third again of the same dimension. Otherwise, this would not work. Here, the dimension wouldn't matter because the scalar would be multiplied with everything. So here, m would have to be equal to m would have to be equal to p, n would have to be equal to q, and all of these would have actually required this to come out, which would have been something like m cross q, or even something like p cross n. You could have written anyway if they were equal. In this case, this multiplication can be performed as long as n and p are equal. So 2 and 2 are equal, so this can be performed, and the resulting one is always mq. So let me show an example. Say I had a 3 by 4 matrix here and a 4 by 5 matrix here. Can this matrix be multiplied? Yes, because this is equal to this, and the resulting one, whatever it would be of the dimensions 3, 5. That is m and q. And as you can see, n and p are the same. That's how we establish every system. Right, so let's look at the problems now. So the first problem is of dimension 3 cross 2, and this is of 3 cross 3, the next one. Can this be done? No. This cannot be done as 2 is not equal to 3. So part A just cannot be solved. Let's look at part B. Part B can be done because it's 3 cross 3 and 3 cross 3. So I'll write the values 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 1, 0, 0, 1, 1, 1, 0, 1. I hope I don't make arithmetic mistakes here. There are calculators available for this online as well, so if you really just want to check your answers very quickly, you can always use those calculators. You can just search matrix multiplication calculators or use Wolfram Alpha, Desmos. There are all kinds of things available. So this and this, so that is 1 plus 3, that is 1 plus 2, that is 2 plus 3 is 4 plus 6, that is 4 plus 5, 5 plus 6, 7 plus 9, 7 plus 8, 8 plus 9. And obviously simplifying this is rather trivial, but let's do it just for the sake of, this is not a very difficult question. This is in fact the easiest question we've encountered in this exercise. The ones before this were significantly harder, and the ones that will follow will be harder. But it's nice to have a change of pace and difficulty. Right, now I hope that's correct. I just make a lot of arithmetic errors all the time, so I don't know. But yeah, let's hope. Right, now let's look at C. I won't write this down. Let's just look at the dimensions now. So C is again 3 by 3 and 3 by 3, so it can be multiplied. So since it can be multiplied, let's write everything down. An interesting thing that I hope many of you noticed is that this is exactly like the last part, with the difference that it's the other way around. And what you'll notice is that matrix multiplication is not commutative. So if you simply flip this order, the multiplication gives a different response. So last time we had a certain answer, which was 4, 3, 5 on the first row, 10, 9, 11, 16, 15, 17. If you now do this, you will find that this is 1 plus 4. This is 4 plus 7. This is 1 plus 7. This is 2 plus 5. 3 plus 6. 5 plus 8. 2 plus 8. 3 plus 9. 6 plus 9. Which when we simplify looks like 5 here, and 11, 8, 13, 10, 7, 9, 15, 12. This is not equal to what we had earlier, which was 4, 3, 5, 10, 9, 11, 16, 15, 17. So if you're given two matrices A and B, their multiplication is generally not the same. It can be. It's not like it always is not the same, but just generally not true. So you cannot just interchange orders. You know how in algebra we could always say AB is equal to BA if this is an integer, if this is an integer. Yes, because the operation of multiplication in this set of integers is commutative, which in this case it isn't. So something to think about. Yes, so this was part C. Sorry, I forgot to write that. Think about part D now. Well, part D, let's think about dimensions again. So 2 cross 4 and 4 cross 2, that can work. And the resulting one would be 2 cross 2. Why? This and this. This goes here, that goes there, sort of thing. So that does work. Now let's write this down. Oh, my bad. Oh well, I'll write this here. Sorry about that. 1, 2, 1, 2, 4, 1, minus 1 minus 4, 0, 3, 1, minus 1, 2, 1, 5, 2. We do this and this will be multiplied by this correspondingly and added. I'll just do that myself here. That'd be 0 plus 2 plus 2, that's 4, plus 10, so that's 14. Then this and this, so 3 minus 2 is 1, plus 1 is 2, plus 4 is 6. Let's look at this. This is 0, 1, minus 2, minus 1, minus 1 times, so minus 1 minus 20 is minus 21, and this is 4, 3, 12. Let me do some jottings here so I don't mess the numbers up. So that would be 8, so 4 minus 2, that is just 2. That is the result for D. Right, that was fairly straightforward. Yeah, let me not waste a lot of paper and just use some paper from our previous answers. Yeah, I think I can just use this. And let's look at E now. E has dimensions of 4 cross 2 and then 2 cross 4. Can this be done? Yes. Why? These are the same. What would be the resulting one? 4 cross 4. Now this is a fairly large matrix. So let's ensure that we chart out everything very neatly this time. 0, 3, 1 minus 1, 2, 1, 5, 2. It is interesting, right? Like when you multiply 4 to 4, you get a very large matrix. But had you flipped this, the order of multiplying them, you would have gotten a much smaller matrix. This is again another thing. They're not commutative, especially the dimensions are different. Then definitely, because if two matrices have different dimensions, then they just cannot be equal. That's interesting. You get 1, 4, 2, 1, 1 minus 1, 2, 4. It's going to be massive. So remember, you're going to take a row and don't get confused with columns and rows. I do that all the time myself. Let's hope you would be sharper on that. So that would just be 12. That would be, so remember in this case, every first element will be 0 and only 3 multiplied the second element. So that is 3, that is minus 3, and that is, 4 times 3 is 12 again, my bad. My God. Anyways, 1, that is 1 minus 4, 2 minus 1, 1 plus 1, 2 minus 4, 2 plus 4, 4 plus 1, 2 minus 1, 4 plus 4, 5 plus 8, 10 plus 2, 5 minus 2, 10 plus 8. Righto. Let me write the answer for that here. That would be 12, 3 minus 3, 12, minus 3, 1, 2, minus 2, 6, 5, 1, 8, 13, 12, 3, 18. Again, there might be minor arithmetic errors in this, but the approach is generally solid, and this is how it must be done. Right, thanks.